I just learned, remember me complaining at the first session of this board about Microsoft's Movie Maker. When I switched on, when I switched on my iPad, somehow that corrupted the file, the movie file, as it was being pre-processed. So I thought, alright, I'll eliminate that file and I will just download it again from the camcorder and try again. And it's still corrupted. So, yeah, there's some memory somewhere. So, unless I can figure out what that residue is and get rid of that, I'm just going to have to refilm that particular part again. So, you know, this process is frustrating, as you can imagine. Alright, so now we will not get very far in analysing this third example. Well, because we just run out of space. But there will be enough time, well, space, to give you the broad picture, you know, the global strategy, so to speak, of what the task is. So I will get, I'll need 3 pens, just a minute. Remember we're talking about stages, sort of, they would be blocks of transition rules where some subtask gets performed. Now, so what I'll give you now is the global strategy. Now, I hope you thought about how to do it. Now, it'd be interesting, well, I probably won't know how, but if you came up with a different one than compared to what I'm going to give you now. But I could do a third different one. Do I have a different, like a pencil or something? Yeah, just a minute. Right, so I have here now three different pens, and the marker pen corresponds to your block of A's, symbol A's on your tape, right? And the middle one, that's a ballpoint pen. I think the next two are ballpoint pens. Well, anyway, this yellowy middle one is the block of B's, and this one the block of C's. Okay. Now the global strategy is following. You're trying to see if the number of A's times the number of B's equals the number of C's. Right. So here's the strategy used by this machine, M3, isn't it? Yeah, M3, the third Turing machine example we're dealing with. Okay. Well, the first thing is you scan right across with the Turing machine acting like a finite automaton to see that the language is in the form A to the I, well, A star, B star, C star. Sorry, the string is in the form A star, B star, C star. Okay, that was your first check. And then you scan right across, you check that it's okay. If it's not, reject, otherwise okay. So you hit the end of your C's. You see your first blank, and then you head back to here, back to your start. All right. Now you look at your first A, and you what do? You cross it off. Let's see what. Cross. Yeah, you cross off. You cross off your first A, right? And then you look at your B's, and you cross off you cross off all the B's. And each time you see a B, you scan to the C's and cross off a corresponding C. So what what you're doing in effect, and the thought's just dawned on me right now, what you're doing in effect now is similar to what you did in the previous example with your your W#W example. So what you're doing now is for each B here that you cross off a corresponding C in the C band, if you like, the block of C's, until all the B's are crossed off and as many C's have been crossed off. Now if I times j equals k, if that's true, then the number of C's you have is going to be a lot more than the number of B's, and in fact it'll be a times more. Okay, that's the whole point. All right. Okay, so let's see. So you've crossed off all your B's here, and you've crossed off as many C's here. Now I'm glossing over a few of the detail. I'm just trying to give the big picture. All right, then you scan back, right back to your A's until you meet your first X that you put. The first A got overwritten by X. Okay, now you come to your next. You move back to your. It'll be your second A, and you cross it off. You put an X there, and then you back in the same loop. Oh, by the way, in coming back the first time, you restore your B's, so the X's in the B's become B's again, and you restore them. Okay. And okay, now you cross off your second A, and you're in the same loop again. So you cross off, each B. For the number of B's here, you cross off an equal number of B's in your C band. You're probably getting the idea now, okay? So you can see where it's going, all right? Okay, so you just do this each time you head back. You restore the B's, so all the X's here become B's again, right? Until you get your next A, cross it off, and then you cross off all the B's here and an equal number of C's in the C band, and you keep doing that until eventually there are no A's left. Okay, and so you go through the last time. So you cross off as many B's, you cross off as many C's as there are B's, and then you check to see if there are any C's left. If there are, reject. But if it's a blank, so the length of your C's is correct. Now, can you see what's going on? How many times does this block of B's get cut away from your C's? Well, A times, because you go through this loop A times, because each time you get an A here that has not been X'd, not crossed out. The number of A's determines the number of times you go through this BC loop in a sense. Okay? You will remove the number of B's from your C's, and you'll do that a number of times that's equal to the number of A's in your A band. Okay? Does that make sense? Hope you follow that reasoning. That's the broad strategy. Okay. Now I've left out a few details, but that's the overview. And then you try to implement that broad strategy, the global strategy, in terms of your Turing machine. Now we won't get into it very far because just ran out of space. So that. Down to here is what I've been saying verbally. All right, now let's examine the stages a bit more closely. So he's talking about four stages of this machine. The first stage is when you just scanned across. You scanned across the machine. To see if it was in the form of A star. You scan across the string to see if the string was of the form A star, B star, C star. Okay, that's stage one. And during that stage, the Turing machine acts as a finite automaton, behaves like a finite automaton, just to see that the string is of that form. Right. Okay, stage two. There's a subtlety. how do you know when the header is coming back? So this is the block of A's. So it's coming back. How do you know? How does the machine know it's at the end of this block of A's? Well, you have to put some kind of marker there. It was similar kind of reasoning of adding the $sign, if you remember, to the stack when we were talking about the PDAs, the push down automata. We had a similar problem. So how do you know when you're at the end of when the stack is empty? Well, you put in this initial $. Well, you can do something similar here. So what you do is the very first symbol in your block of A's, that first A will get overwritten by something, and that's something you can look on as an leftmost end marker, like the end or the very beginning, in fact, of your string. Right? That'll be some indicator that when you come back and you reach the end, you'll know it, because the next thing there is no next thing, which is Sipser's way odd. I prefer just to have blanks left side and blanks right side. And when you hit your blank, that's the end. Right. Okay. Right. So stage 2, you have this problem. So you need to the very first symbol you replace. You overwrite it with something, and that something then, from then on, is your indicator that you've reached the end, or actually the beginning, well, the end of the left-hand end of your tape. Okay. All right. Now, there's another way you can do it. That'll be mentioned. It's a bit trickier, and it involves when you do attempt to move off the end of the tape with a move, you don't move. I mean, the state can change, and the writing, what you write, I mean, that can be all done, but the move part, the LR part, doesn't get executed. You just stay where you are. Now you can use that to detect whether you're at the left-hand end of your tape, and that's run out of board. So I think I've covered it, right? Yeah, I think so. So that's the end of that session, and I will have to refilm the last part of an earlier session, thanks to Microsoft. So from now on, I will get into a strict habit. I will just not multitask while Movie Maker is running, and that is a pain because it takes up so much time. I want to do other things, but it's not letting me. Ciao.